Good morning, learners and all viewers. Welcome once again for today's mathematics lesson. My name is Enoch Asera. Today, I wish to take you through construction of quadrilaterals. Now, last time you were taken through construction of triangle and also construction of circle passing through the vertices and also the sides. Today I want us to continue from where the teacher stopped. That is construction of quadrilaterals. Well, before we start doing that, make sure that you have a pencil with you, you have a rubber or an eraser, and also a sharp pencil. The other thing that is very important before we continue with the construction is that you need to be very accurate. Construction needs a lot of accuracy, and also your work has to be neat. Now, starting with quadrilateral, we'll first take you through what it means. Now, quadrilaterals, these are just four-sided figure. A quadrilateral is a four-sided figure. Quadrilateral is a four-sided figure. A four-sided figure. Any figure that has got four sides is called a quadrilateral. Now, the other unique thing about quadrilateral is that total angle or total interior angle or angles add up to 360 degrees. This is very, very important, learners, because this is something that sometimes is always said, whereby you are asked which of the following is true about quadrilateral. So the two properties that I've given about quadrilateral are the ones that the quadrilaterals that I'm going to discuss here share. So all those figures must have four sides. At the same time, the total interior angles must add up to 360 degrees. Now, you will find that as we continue, you will find that there are other properties that are not shared by all quadrilaterals. So these two properties are the ones that are shared by all the quadrilaterals. I repeat, these two properties are the ones that are shared by all the quadrilaterals. That is, a quadrilateral must have four sides. At the same time, the total interior angles must also add up to 360 degrees. Now, some of the examples of quadrilaterals include one, square. So we have one square. Square is a quadrilateral. We'll discuss about the properties of each and every quadrilateral that I'm going to mention here. And then the second one is rectangle. So rectangle is also another example of quadrilateral. We also have rhombus. And then number 4, we have parallelogram. Parallelogram is the fourth one. So then finally we have trapezium. So these five quadrilaterals are the ones that I'm going to discuss. Now somebody might be asking him or herself the reason as to why I've decided to go through the properties of quadrilaterals. You cannot construct this quadrilaterals if you don't understand their properties. And that is why I've decided to go through this with you so that you can be able to understand them and see whether you can be able to construct these 5 quadrilaterals. So very first, I will start with the square. I'll start with the square. Now, square is a 4-sided figure. Let me just draw it here for you so that you can also be able to see how it looks. So a square is an example of a quadrilateral that has 4 sides. So the first property of a square. Let me just give you the properties first. Then I'll draw it later on using the compass and protractor, so that I can be able to draw a well-drawn diagram. Now, the first property of a square is that it has 4 sides. Like I said earlier, these 2 properties of quadrilaterals are shared by all the 5 quadrilaterals I've written here. So the second property of a square is that each interior angle is a right angle. Each interior angle is a right angle. That is, it's 90 degrees. Each interior angle is a right angle. The third property of a square is that it has 2 pairs. It has 2 pairs of parallel lines. It has 2 pairs of parallel lines. The fourth property of a square is that the diagonals are equal. Then the fifth one is that diagonals bisect at 90 degrees. Diagonals bisect at right angle. Diagonals bisect at right angle. So that means that they bisect at 90 degrees. Well, the other property of a square is that opposite sides are parallel. Opposite sides are parallel. Okay, so very fast, let me draw it for you here. So we can just have maybe we draw square ABCD with sides for AB is 4 centimeters. AB is 4 centimeters. So we start by drawing a line, straight line. After drawing the straight line, then you measure 4 centimeters. You measure 4 centimeters from your ruler. Measure 4 centimeters. After measuring 4 centimeters, then you stand at any point on the line. Draw an arc. Once, don't keep on repeating. Come back here, draw the other arc, like that. And then Name that square as AB. Name it AB. Now, you know very well that a square has got all sides equal, and each angle is 90 degrees. So we can construct an angle of 90 degrees without using the protractor, or we can also draw that angle when you use the protractor. So let me just use protractor here. So we measure 90 degrees. So 90 degrees is at this point. So you put a dot. Put a dot. After putting the dot, also come this side, because each interior angle is 90 degrees. Do the same. Put the angle there. And then after that, then we need to find the length of side BC. So you come again, you measure 4 centimeters. You measure 4 centimeters. 4 centimeters. And then you stand at point A, draw an arc above, above the dot. Repeat the same while standing at B. Draw the arc above the dot, because the dot gives you where the angle is. After that, then you join. You join up to where the arc is, having in mind where the dot is. So make sure that your line is passing through the dot, like that. Then also come this side, do the same. Make sure that the line is passing through the dot. All right. Then from there, then we join this part here. Join this part. So join this like that. So if you look at the figure that I've just drawn, you'll find that this AB, CD. So you'll find that this line AD, line AB, line BC, and line CD are all equal. So this is 4 centimeters, this is 4 centimeters, this is 4 centimeters. Now, then we say that it has 4 sides. As you can see, there are 4 sides. Each interior angle is right angle. So if you measure here, you're supposed to get 90 degrees. So this is 90 degrees. This is also 90 degrees. This is also 90 degrees. And this is also 90 degrees. Then after that, we have also said that it has 2 pair of parallel lines. So this line, line AB and line DC are parallel. Parallel lines are lines that cannot meet. So even if you extend, they will still not meet. And then we have said, so this is one pair. This and this is one pair. And then we also have line AD and BC, which are also parallel. So that line, that is line AD and line BC, are also parallel to one another. And that's why here we have said it has 2 pair of parallel lines. Now, for your information, all quadrilaterals, these 5 quadrilaterals that I've written here, have got these 4 square, rectangle, rhombus, parallelogram. They have 2 pair of parallel lines, except trapezium that has got only one pair of parallel line. So we move to the next. We say diagonals are equal. Now, diagonals, we can join line AC, join line AC, join line AC, and then join line AC, and also I want us to join also line BD. So you make sure that it passes through the points. So that is diagonal. Line AC is one of the diagonals, and also we also have we also join line BD, or these 2 points, like that. So these diagonals are equal. These diagonals are equal. If you measure from here to here is 5.5, and then here is also 5.5. So the diagonals are equal. This diagonal is equal to this diagonal. Now the other thing we have said about square is that the diagonals bisect at 90 degrees. The diagonals bisect at 90 degrees. So then if we measure this angle here, as you can see, if we measure that angle, you will see that it is 90 degrees. So that is why it is true to say that the diagonal bisect each other at 90 degrees. So all these measures 90 degrees. All these measures 90 degrees. And then we have also said that the opposite sides are parallel. Opposite sides are parallel, as you can see. Line AB is parallel to line DC. So that is exactly what a square is all about. I wish to take you through the next one, which is the rhombus. The next one, which is the rhombus. So right here, rhombus. Properties of a rhombus. Properties of a rhombus. Now the first property of a rhombus, property of a rhombus. Property of a rhombus. Properties of a rhombus. Now, after discussing about properties of a rhombus, I want us to compare the two, that is square and the rhombus. Now, the first property of a rhombus, just like a square, rhombus has 4 sides. Remember, I told you that these 5 quadrilaterals, one thing, or all quadrilateral, 2 things that are always common is that they have 4 sides. At the same time, the interior angles add up to 360 degrees. So the first property of a rhombus is that it has 4 sides. Number 2 about rhombus is that opposite sides are equal and parallel. Opposite sides are equal and parallel. Then the third property of a rhombus is that diagonals are varied. That means that diagonals are not equal. So let me write here in brackets. Diagonal are varied. That means that diagonals are not equal. But bisect at right angle. Diagonals are not equal, but bisect at right angle. The diagonals are not equal, but bisect at right angle. Now, when we were talking about square, we said diagonals are equal. So this diagonal here, diagonal AC and diagonal DB are equal. But with the rhombus, the diagonals are not equal, but just like a square, diagonals bisect at 90 degrees. So that is a very important part that you need to understand. Now, after I will have drawn the rhombus, you'll be able to see whether that is true. Number four, the fourth property of a rhombus is that has two pairs of parallel lines. Has two pairs of parallel lines, just like a square. And then the fifth property of a rhombus is that opposite angles are equal. I will explain that after I will have drawn it. Then number 6 is that adjacent angles add up to 180. Or we can also say adjacent angles are supplementary. Now, supplementary angles are angles that add up to 180 degrees. So if you add the adjacent angles, then you'll be able to find out that they will add or they will sum up to 180 degrees. Okay, the next property of a rhombus is that all sides are equal. Then the eighth one, rhombus is a special parallelogram. But parallelogram cannot be a special rhombus. So that is also another area that is always confusing. Rhombus is a special parallelogram, but parallelogram is not a special rhombus. In fact, these four, that is square, rectangle, rhombus, are all special parallelograms. But the vice versa is not true. That is, it will be wrong if you say that parallelogram is a special rhombus. It will also be wrong to say parallelogram is a special rectangle. That is very, very wrong. So make sure that you understand that rhombus, square, rectangle are all special parallelogram. The vice versa is not true. That is, parallelogram cannot be a special rhombus. Now, having talked about the properties of a rhombus, I want us to construct a rhombus here, and then you can be able to find out whether those properties that I've just written are true. So we'll start by drawing a line. Start by drawing a line here. So the parallelogram that we are drawing is WXYZ with side WX is 3 centimeters, and then we need to have one angle. So angle WXY can use 50 degrees. So we start by drawing a line here. Straight one, like the one I've drawn. Then after that, we are constructing a rhombus WXYZ with side WX 3 centimeter. Now, remember we say that a rhombus has got all sides being equal. So if line WX is 3, that means that the other sides, the other 3 remaining sides, are also 3 centimeters because all the sides of a rhombus are equal. So we come here using the compass, then we measure 3 centimeters. So we measure 3 centimeters. Okay, so 3 centimeters. Okay, now that 3 centimeters, I stand at any point on the line. I draw an arc on that side. I come back here. I also draw the arc like that. Then after that, we name it. We name it X, line WX. Line WX, 3 centimeters. After doing that, then we are told that angle WXY is 50 degrees. Angle WXY is 50 degrees. So normally, when we are finding out the angle, we look at the letter that is at the middle letter. In this case, the middle letter is X. And because on our line, we have point X, so you put your protractor at that point. You put your protractor at that point, at X. Put your protractor at X. Then, since the line is on this side, then we need to find the angle on this side. Remember, your protractor has got 2 scales. We have the inner scale and we have the outer scale. It is important that you use the correct scale. Now, the line will always guide you on which scale to use. Now, since our line is on this side, then we are supposed to look at the angle of the scale that's on this side. Now, the 0 must start from this side where the line is. Now, in this case, we are going to use the outer scale. So we measure 50 degrees. So 50 degrees is here. So you put a dot, like I've just put mine. Then you remove your protractor. Then, where the dot is does not mean that the line is going to end there. What you need to do, again, is to measure the 3 centimeters. Remember, I told you that one of the property of a rhombus is that all of its sides are equal. And since we were given one side, that is the side that we are going to use. So again, 3 centimeters. Now, after measuring 3 centimeters, then you stand at X. The dot will guide you on where to put the arc. You don't just have to put arcs anyhow. Where the dot is, you can put the arc above it or below it. It depends with where the dot is. Again, I say that the dot does not determine where the line will reach. Because I've seen sometimes learners, after putting the dot here, they think that the line will reach where the dot is. The line can be above the dot or below the dot. So put the arc above that dot, like that. You don't have to put it this side because the dot is here. The dot determines, of course, the dot we said this is where the angle is. So it won't be necessary. It will not be necessary if you draw the arc on that side. The dot will determine where the line will reach. Then join that line. Join that line. Join that line. So I come here using a ruler. So I draw the arc, the line, make sure that it passes through the dot and also it reaches where the arc was. So this angle here is 50 degrees. That angle there is 50 degrees. So you indicate 50 degrees. Now, I hope you have seen a situation whereby a figure has been drawn like this, and then you're asked to complete it. You have seen a situation whereby a figure has been drawn like this, and then you're asked to complete it. So what you need to do here is that the properties that we have discussed earlier are going to help you complete this, this figure here. So you can do that by using the sides. Now, since all the sides of a rhombus are equal. So you stand at W, then you put an arc like that. Then again, come back to, this should be WX, Y. So again, you stand at, after putting an arc above W like that, then again lift it, come at Y, again you draw the arc like that. Where the two lines have intersected at is point Z. So this is Z. So now you can complete by joining line WZ, can complete it by joining line WZ. I said accuracy is key here, and don't keep on drawing the lines. Just do it once and be very accurate. Again, you come at this point, then you join the line. Your parallelogram, your rhombus is completely drawn. Now, we want to confirm the properties that I discussed earlier. Now, there is something here. I will start by 4 sides. So if you look at this, it has 4 sides, and the sides are equal. So this is 3 centimeters, this is 3 centimeters, and this is also 3 centimeters. Opposite sides are equal and parallel. So these opposite sides are equal and parallel. So I said parallel lines are lines that cannot meet and will never meet. So has 2 pairs. This and this makes 1 pair. This and this also makes a pair. And then we also say that diagonals are varied, not equal, but bisect at right angle. So I want us to join line WY, line WY, line WY, and also line WZ, and also line WZ. So we join it like that. If you keenly observe this rhombus, it is evident that line ZX is longer than line WY. And that's why we said here that diagonals are varied. This diagonal and this diagonal are not equal. But we also say that they bisect at 90 degrees. So we can also find out that. Just take your protractor and then you measure. Take your protractor and then you measure. So you can say where the 2 arcs meet. You can name it O. Where the 2 diagonals meet, you can name it O. And then now we come here and measure. Come here and measure. If you look at this, it is evident again that this is 90 degrees. 90 degrees. So learners and viewers, all these properties that I've written here, you can see that they are all true. Now the other part that I want to mention is that adjacent angles add up to 180 degrees. So adjacent angles are these angles. So this one and this one must add up to 180. Now if this is 50, this one should be 130. So that when you add this and this, you get 180. The other thing we talked about, we said the opposite angles, this angle here, angle ZWX and angle ZYX are equal. So this is also 130 degrees, this is also 130 degrees. Now opposite angles, this angle here and this angle here are opposite and equal. So that is simply the property of a rhombus. I want to take you through another quadrilateral, that is parallelogram. That is parallelogram. So parallelogram is another quadrilateral One of the property of parallelogram is that it has 4 sides. Parallelogram. So number 1, it has 4 sides. Has 4 sides. Has 4 sides. Number 2, opposite angles are equal. Opposite angles are equal. Number 3, adjacent angles add up to 180 degrees. Number 4, has two pair of parallel lines. Number 5 is that opposite sides are equal and parallel. Then number 6 is that diagonals are varied. And do not bisect at 90 degrees. So learners and viewers, there's another important thing that you need to understand, and this is a question that's always common, that a square and a rhombus are the only quadrilaterals whose diagonals bisect at 90 degrees. Square and the rhombus are the only quadrilaterals whose diagonals bisect at 90 degrees. But the difference is that diagonals of a square are equal, but diagonals of a rhombus are varied. So it's something that you need to understand, that the only quadrilaterals whose diagonals bisect at 90 degrees is square and a rhombus. Okay, so I want to draw this again for you, so that you can be able to confirm all those properties. So we are going to construct a parallelogram. Okay. So parallelogram. So we can construct parallelogram, maybe ABCD, such that line AB, say 3 centimeters. Line BC, I can maybe give it 5 centimeters. And then angle ABC is 70 degrees. So you start by drawing a straight line. So you draw a straight line. Then after that, you measure line AB, or you can measure line BC, 5 centimeters. So line BC is 5 centimeters. Use a compass to measure 5 centimeters. BC is 5 centimeters. So you stand at this point, draw an arc, then come back here and draw another arc. Okay, then after that you name it. This is line AB. So we are done with this. Sorry, this is BC, should be BC. And then we are told that line AB is 3 centimeters, BC is 3 centimeters. AB is 3 centimeters. Now, first I want us to measure the angle ABC, which is angle ABC, which is 70 degrees. So standard B, then measure 70 degrees. So again, the line is on this side, and this is the angle that we want. So we check the 0 from this side is in which scale, inner or outer. So this is inner scale. So you measure 70 centimeters, which is there. After that, then you come back and measure 3 centimeters BC, AB, 3 centimeters, so measure 3 centimeters. Standard B, then draw that arc above the dot, like I've indicated there. Then after that, you join line AB, considering where the dot is and where the arc is. So you join it. Sorry, let me just take another marker pen. So you join AB. Okay. So this is A, and this angle here is 70 degrees. Now, just like when we were constructing the rhombus, we said most of the time the question is always like this, and then you're asked to complete it. So you can just complete this, taking into consideration the sides. So this was 3 centimeters. We know that one of the property of a parallelogram is that opposite sides are equal. So if AB is 3, then it means also CD is 3. So you measure 3 and then you draw the arc like that. Then, because line BC is 5, then it also line AD is going to be 5. Reason? The opposite sides are equal and parallel. So just draw that arc like that, so that they intersect like the way they have intersected. So where they have intersected is D. It's D. Then now you can join. Point AD or line AD as a. So you can join it like that. Then also join line DC like that. So after joining, then we can start discussing about the properties. We said opposite, you can see there are 4 sides. So this line and this line, that is line AD and line BC, are parallel. Line AB and line DC are also parallel. The other thing we said is that opposite angles are equal. So if this is angle ABC is 70, then it means also angle CDA is also going to be 70 degrees. Then angle, this angle and this angle, that is angle BAD and angle ADC, that is this one and this one, they are adjacent. Adjacent angles add up to 180 degrees. So when you take 180 minus 70, you'll get 110 degrees. Now, if angle BAD is 110 degrees, then it also means that angle BCD is also 110 degrees. That because the opposite angles of a parallelogram are equal. And then we also say that diagonals are varied. That means that the diagonals are not equal and they do not bisect at 90 degrees. The only quadrilaterals whose diagonals bisect at 90 degrees include square and a rhombus. Square and a rhombus. So that one like that. So we have, so this diagonal, that's diagonal AC and diagonal BD, they are not equal. It's very evident. Now, this diagonal, that is diagonal BD, is longer than diagonal AC. Now, we said that those diagonals, they don't bisect at 90 degrees. So you can see the line 90 degrees is here, and the line 90 degrees is here, but the line is here. So it's automatically that it's not 90 degrees. So this one is not 90 degrees. And then we move to the next quadrilateral. That is rectangle. That is rectangle. So let me use this part here. Rectangle. Now rectangle, just like the other quadrilaterals, has 4 sides. Rectangle has 4 sides. So number 1 has 4 sides. Number 2, opposite angles. Opposite sides are equal. Each interior angle is 90 degrees. Number 4, diagonals are equal, but do not bisect at 90 degrees. They are equal, but they do not bisect at 90 degrees. Has two pairs of parallel lines. Has 2 pairs of parallel lines. Diagonals are equal but not bisect. Each interior angle is 90. So these are some of the characteristics of a rectangle. Drawing a rectangle is just like follow the same procedure, just like a square. Then we have trapezium. Now, trapezium is the only quadrilateral that has one pair of parallel line. One pair of parallel line. So this trapezium is the only quadrilateral that has one pair of parallel lines. The other 4 that I've just discussed, have 2 pairs of parallel line. So this is a unique property of a trapezium. This is a unique property of a trapezium. Many times you can be asked this question, so make sure that you don't miss it. This is the only quadrilateral that has one pair of parallel line, as you have seen on the slide. It doesn't have so many properties, unlike the 4 that have discussed previously. Now, you can have 2, maybe I'll sketch here before I draw it for you. Now, this one and this one, if this one and this ones are equal, then this trapezium is called isosceles trapezium. And then we also have the other one. I want to draw this. Then we have this one here. Now this one here is called a right angle trapezium because this angle here is 90 degrees. As you can see, only these lines are parallel, and this line makes what we call a pair. That is one pair. Again, this one and these ones, they are not parallel. If you extend, I said that parallel lines are lines that cannot meet. So if you extend these lines, they'll meet at a certain point, and that disqualify it as having two pairs of parallel lines. So we only have one pair here, as you can see. So I want to construct a trapezium for you. I want to construct one trapezium here for you, so that we can be able to understand how easy it is to construct it. So I'll use this side. Okay. All right. So I want us to construct trapezium ABCD, trapezium ABCD, such that AB, that is line AB, such that line AB is 5 centimeters, 5 centimeters. Angle ABC is equal to angle ABC is equal to angle BAD, which is equal to 60 degrees. And then we also have line AD is equal to line BC is equal to 4 centimeters. Line AD is equal to line BC is equal to 4 centimeters. Now, and then after that, we can be able to answer a few questions there. So what we are supposed to do, learners, is that we draw a straight line. We draw a straight line. So we'll start with the line AB. Start with line AB. So put your ruler like that. Draw a very straight line, like I've just drawn. And then after drawing line AB, straight line like that, then we measure 5 centimeters. We measure 5 centimeters. So come with your compass, measure 5 centimeters. 5 centimeters. 5 centimeters is there. So stand at any point on the line, then draw an arc like that. Come back again here. Make sure that you're very accurate. Construction needs a lot of accuracy. And don't shake. Don't shake. So that is line AB. So indicate. It is important to indicate as you proceed with your construction. Then after that, we are told that line AD and line BC is 4 centimeters. Now the first thing that I want us to do is to measure the angles. So take your protractor. Take your protractor. Take your protractor. Angle ABC, so we are looking at, we'll stand at B, at point D, and at the same time we'll also stand at point A. Now, angle ABC and angle BAD are equal, and they measure 60 degrees. So stand at A, like I've indicated. Then, because the line is this side, so you have to find the angle on this side. Now, we say that you have to check the scale that you're supposed to use. So the 0 from this side is found on the inner scale. So we start, then we measure 60. So 60 is there. Put a dot. After putting the dot, then you come and also measure the line. We are also told that line AD is equal to BC is equal to 4 centimeters. So measure 4 centimeters. Measure 4 centimeters. After measuring 4 centimeters, stand at A and then draw an arc above the dot. The dot will guide you on where to draw the arc. So draw the arc above the dot, like that. And then, okay, so this side also, we draw the arc above the dot. Oh, so let me just join this first. So let's join this part here. So this is 60 degrees. And then also, we also measure 60 degrees from B. So 60 degrees. So this time round, we are using the outer scale. So it's reaching at this point. So put the dot. So putting the dot, then you also measure 4 centimeters. Stand at B, draw the arc above the dot. After that, then you join the line. So you join the line, having in mind where the dot is, because the dot will guide you. So that. Then after that, this is D, where the arc is D, and the other one should be C. So this is D and this is C. After that, you join line DC. Join line DC, like I've joined it. So this is a trapezium, isosceles one, since this one and this one are equal. You can also drop perpendicular. That's the next thing that, if time will allow me, I'll take you through so that you can be able to understand how perpendicular line can be dropped. So if you look at this line here and this line here, they are parallel to one another. That means that this is the only pair of parallel line that we have. That's the only pair of parallel line that we have. So that is basically how you can be able to draw an isosceles trapezium, because this is 4 centimeters. Sorry, this is 4 centimeters, yes, and this is also 4 centimeters. This line is 5 centimeters. So sometimes you can just drop that so that this can be 90 degrees. So that is how you should be able to drop a perpendicular line. Now, I want to take you through another. I want to take you through how we can be able to construct, to drop a perpendicular line from a point. How to drop a perpendicular line from a point. So let me use this side. How to drop a perpendicular line from a point. So this is another area that you need to understand so that you can be able to answer the questions correctly. Now, I just want to start with any triangle or any rhombus or any parallelogram. So let me draw parallelogram here. So you can have a parallelogram. Let's say this is parallelogram AB. So draw the arcs, the lines, and all the points. So this is, let's say, parallelogram ABCD. So AB is 4 centimeters. 4 centimeters. So this is AB, 4 centimeters. So you can name it AB, 4 centimeters. Now this is dropping 4 perpendicular, dropping perpendicular bisector from a point, dropping perpendicular bisector from a point. So line AB is 4 centimeters, and then maybe the angle is 50. The angle is 50 degrees. Angle ABC is 50. So you stand at that point. This is the side that you want. So you measure 50 degrees or 60, whichever you want. Line AB is 4 centimeters, and then angle ABC is 50 degrees, and then line BC is 5 centimeters. It's 5 centimeters, so we can use that information. So the angle is there already, and line BC is 5 centimeters, so you measure 5 centimeters again, 5 centimeters. So 5 centimeters is there. So, okay, this one will go this side. So I need to extend this line. This will go on the other side. This one will disturb us. So very fast, and draw the line again. So you do that. Then AB is 4 centimeters. So you measure 4 centimeters. 4 centimeters is there. 4 centimeters. Okay. Then the angle is 50 degrees. The angle is 50 degrees. That is angle ABC. ABC. It should be AB. So this is 50. So you put your compass there. Measure 50. Put the dot. And then you measure 5 centimeters. You measure 5 centimeters. So I'll put the ruler here, the compass here. I measure 5 centimeters there. So I put it above the dot. So this is 5. Remember, this line BC and line AD are parallel. So you can also put the arc there. That is 5, 5. Then after that, then we are told that we can join this line first. That is line BC. BC. So take into consideration where the dot is, because that is the angle. Okay. So you join it like that. So this is C. And then after that, then you can complete the figure. Since this is 4, this is 4, this is how to complete it. Since from here to here is 4, it means also from here to here is also going to be 4. So where they intersect at is your point D. Now you can join point AD, and join point AD, and join point AD like that, and then you can also join point DC. Now, you can indicate this was 50 degrees, and then this is going to be 130 degrees. Of course, this one is also 130 degrees, and this is 50 degrees. Now, most of the questions that are always set is that you can be asked, join diagonal DB and also diagonal AC, and then find a half the longer diagonal. Find half the longer diagonal. So if you're asked to find half the longer diagonal, then you're supposed to measure the diagonal itself In this case, this one is the longer one, dB. After measuring dB, then you divide by 2. If you are told to find the length of half the shorter diagonal, then again you will have to measure this and then you divide by 2. So you need to be very careful so that you can be able to understand the examiner's question. Sometimes learners fail because of rushing. It is important you understand the question so that you can be able to get the correct answer. So after you have measured dB, because that is the longer diagonal, then you read the question, because you will find that the measurement of line dB, and the question probably is asking half the diagonal. So that means that after finding line dB, you're supposed to divide by 2 in order to get your answer. Now, dropping perpendicular bisector from a point. Now, let's say you want to, the question was, drop a perpendicular from point C to meet line AB at DOT. Drop perpendicular from C to meet line AB at C or at O. Drop perpendicular from C. So the keyword is from C. So how do you drop a perpendicular line or a perpendicular bisector? You'd stand at point C. After standing at point C, then find appropriate radius. This is where the line is supposed to cut, line AB. So you stand at point D because you have been told to drop it from, from point C. You are told to drop it from point C. So stand at point C and then make sure that you draw an arc that cuts line AB. So draw an arc that cuts line AB. So draw an arc that cuts line AB like that. The question is draw perpendicular from C to meet line AB at O. Now, after drawing an arc, I've just stood here, drawn an arc that cuts line AB on both sides. That is on two sides, there and here. After doing that, then you lift your compass, reduce it, stand at where you have the first arc on the other side of the line, then draw an arc above it, come back to, don't interfere with the compass, come back to where you have also the other arc cutting the line, also draw an arc. After doing that, then you join this perpendicular bisector from point C to where the two arcs intersect at. So you do what I'm just doing. So you are told to drop a perpendicular from point C to cut line AB at O. So now where the perpendicular bisector is cutting line AB is where you write O. Don't write O where you have the two arcs intersecting at. So this is point O. Then from here, you can also be told bisect. This is how you are supposed to draw perpendicular. So you can also be told to bisect angle ADC to meet the perpendicular bisector at P. So how do you bisect? How do you bisect the angle? To bisect an angle means to divide into two equal parts. So you stand at D. After standing at D, then you draw an arc like that to cut the line that is forming the angle, because angle D is formed by line AD and line DC. Now, after drawing the arc that cuts both the line AD and line DC, then come to where the first arc is, then draw the arc here, come back here, draw the arc also here. I'm saying you can be told after dropping the perpendicular bisector, you can also be told to bisect angle ADC such that the angle bisector meets the perpendicular bisector at P. So after doing what I've just done on the whiteboard, then you join the line. You join the line. So that is bisecting that. So you join this line here, like I'm just joining it, like that. So where this is angle bisector. Angle bisector bisect an angle, and this one is at perpendicular bisector. So where this angle bisector meets line CO is probably P. Then now from here you can be told measure, can be told to measure line line, measure line DP. You can also be told to measure this angle here. That is angle, measure angle DPO. So many questions can be asked from this point. So learners, it is important you know how to bisect an angle, how to drop perpendicular bisector. Now, as I wind up, I want to take you through some of the questions, KCP questions that have always been tested. I always look at the last 10 years. So this is on the, maybe you can show them on the slide. So in 2019, that is last year, in 2019, the question was in number 28. And there you are told to construct a parallelogram, whereby after constructing the parallelogram, you are asked to find half the longer diagonal. I hope that is a question that you can handle at home. Now in 2018, it was number 9, and this was also about properties of quadrilateral. The two quadrilaterals that I mentioned earlier, I said there are only two quadrilaterals. I mean, there are only two properties of quadrilateral that are shared by the 4 quadrilateral. That is having 4 sides, and also the total angle of interior angle add up to 360. Then in 2017, it was number 15, whereby you are expected to draw a parallelogram. After drawing a parallelogram, then you are asked to find half the diagonal. You are expected to draw a parallelogram, and then you find half the diagonal. And then in 2016, it was on number 25. This was also about parallelogram. You are just asked to find half the diagonal. And then in 2015, it was on in question number 15. Now here you are expected to draw a parallelogram. After drawing the parallelogram, you are expected to find the shorter diagonal. And then in 2014, there were 2 questions. That is number 17 and number 30, whereby you are expected, in number 17, you are expected to give the property of a rhombus. And those are the same properties that I've just discussed. And in number 30, that is again in 2014, you are expected to draw a rhombus. After drawing the rhombus, then you find the difference in length of diagonal. You find the difference in length of the diagonal. That means that after you had drawn it, after you had drawn the rhombus, you were to measure the 2 diagonals. After measuring the 2 diagonals, then you find their difference. Difference in mathematics means that you're supposed to find you're supposed to minus. And then in 2013, it was number 12. Now this one you are expected to drop a perpendicular, just like I've dropped perpendicular from the last example that I've given you, and then you work out the question. Then in 2011, there was no question in 2012. In 2011, it was number 32. And number 32, you're expected to draw a parallelogram. After drawing the parallelogram, then you find half the diagonal. Then lastly, in 2010, the question was on number 19, whereby you're expected to draw, to give the property of a rhombus and a square. Property of a rhombus and a square. Now, I think now I've been able to do most of the questions. Maybe I'll just try to answer a certain question here. Somebody's asking. Now, remember I said that a rhombus, parallelogram, rhombus rectangle, and a square are special parallelograms. But the vice versa or the other way around is not true. You cannot say parallelogram is a rhombus. You cannot say parallelogram is a square. You cannot say parallelogram is a rectangle. But it is true when you say rhombus is a parallelogram, special parallelogram. Square is a special parallelogram. Rectangle is a special parallelogram. I think now you are good to go. Okay, so I think that is the only question that I can see here as of now. So learners, I hope you have gotten help, and now moving forward, you'll be able to construct quadrilaterals without experiencing any difficulty or without encountering any difficulty. At the same time, I believe that by now you know all the properties of quadrilaterals, whether it is a square, whether it's a rectangle, whether it is a trapezium. You know this is an area that is mostly tested in the national exam, that is KCPE. So it will be very important if you can, you know, go through several questions, and then especially the ones that I gave you the summary, the KCP ones, so that you can be able to understand them better. For now, if maybe you had a question, the numbers are always scrolling on the screen, so you can just get in touch with us so that next time if I will come back, I'll be able to handle them. For now, I wish to thank you all for watching, and keep it locked on KU TV. This is where learning is made easier for you while you're at home. May God bless you all, and make sure that you stay safe. Bye-bye.